All right, ladies and gentlemen, hello and welcome back once again to the Synthesis webinar series. My name is Eric Cavanaugh. I will be your moderator for a fantastic event, folks. We're straddling past, future, and present as we try to understand what is a modern data warehouse. And folks, this is actually quite exciting stuff because we're getting the band back together. That's right, it's myself, Dave Wells, and Wayne Eckerson, who all got together at TDWI many years ago, the Data Warehousing Institute, and our good friend Joy King of Vertica Product Management, VP over there. We're going to talk about what's really happening in this space, and it is a very dynamic space to be in, I can tell you that, folks. So first of all, the agenda. I'll just say a few quick words to set the context, if you will, for the conversation today and tell you a bit about our Synthesis webcast series. So Wayne and Dave and myself in this industry, we've spent many years trying to understand what's really happening out there, and you have to draw a sort of Venn diagram that involves end users, it involves vendors, and it involves analysts and media people trying to sort of piece together what's actually happening. Of course, there's a lot of language that goes out from vendors and from other people marketing solutions, and we try to understand exactly where these terms overlap, where they apply, where they don't apply. And there's been some very interesting conversation over the last 5 to 10 years or so about data lakes versus data warehouses. What is a modern data warehouse? Where are things going? Lots of things are happening, and the purpose of this Synthesis webcast series is really to break down the details and distill what we hear and help you all understand what you need to do to really get your head around modern data warehousing. So we have several webcasts in this series. This is the second one. We will archive all of them for later viewing, so feel free to check those out. But I'd like to just say a couple quick things about how we got here. So I always try to remind folks in data warehousing in particular that many of the solutions that were designed 10 and even 20 years ago were in a much different world. The constraints were much different. We had slower processors. We had thin pipes to move data through. Storage was expensive, for example. These solutions were really quite expensive. You're talking millions of dollars. Well, what happened in the last 2 to 4 years or 5 years? A lot of that stuff turned inside out. Processors are now incredibly fast. We have a lot of parallel processing that's done these days to split up workloads. Storage is nowhere near as expensive as it used to be, and the pipes are a lot fatter too. So what does that mean? Well, you can't really retrofit some of these solutions too effectively. Sometimes you can, but a lot of times you have to embrace a new way of doing things. Well, we're going to hear from Dave Wells, for example, about a very cool concept related to architecture. We're going to hear from Wayne Eckerson, a perspective on what's really going on conceptually, and then we'll also hear some details from Joy King about what those folks are doing at Vertica. And I'll just give you a quick little bit of context as well. It was Michael Stonebreaker himself, Dr. Michael Stonebreaker, who opened my mind way back in 2006 on the topic of database technology. He was promoting Vertica early in the ball game for that company. I interviewed him when I was at TDWI, and he was on a soapbox talking about one size does not fit all. And I remember I did a podcast interview with him back then, and I asked him, well, what do you mean by that? And he said that the relational database became the de facto standard for all use cases regarding data, whether it's transactional systems or analytical systems or whatever the case may be. Relational databases ruled the day, and that was the choice that you went with. Almost everybody did for almost every solution. There were a couple of different vendors doing different things, like Sybase IQ, for example, was a columnar database from way back in the day. But Vertica was his new company, relatively new at the time, and he made some really interesting comments. I asked him, well, why do you think that is? Why is it that relational won the day? And he said that it was because it was just too complicated for sales and marketing people to go out and interface with customers and explain to them the differences. So they said, look, let's just stick with one and go out and sell that. Well, his point was that the one size does not fit all was going to be the new mantra for database technology, and oh my goodness, how right he was. Think about the explosion of databases that came out after that, of a lot of these column-oriented databases, lots of graph databases, object stores, all kinds of different things really spun out and then went crazy in a good way over the last 3 to 5 years with a lot of this big data stuff. But nonetheless, there have been a lot of people who have conflated terms like analytic analytics and data warehousing and business intelligence. And the fact is that the engineering which went into data warehousing is still rock solid today. So it's not the case that you can just migrate over to a data lake, for example. There was a few misconceptions out there to that effect, I would have to argue. So with that, I'm going to hand it off to our first presenter of the day, Mr. Wayne Eckerson, who's going to take us through the conceptual perspective. And with that, Wayne, take it away.
Okay, great. Eric, I think we had a few more slides in here on the synthesis series, but we can come back to that. So my job really is to talk about the modern data warehouse from a conceptual perspective, not to have any diagrams and things like that. I'm going to leave that to Dave and Joy. But I thought I'd just set the stage and build on what Eric just said, is that until about 2010, the data warehouse was essentially the only game in town if you had an application where you wanted to make decisions using data. But that changed at that point in time with the advent of big data and then the cloud and then a whole bunch of new technology, including streaming, and then the price performance of everything growing exponentially. So today, in this world, we can do things with technology that we wanted to do way back when, but couldn't because it was too expensive, and also do things that we couldn't even imagine doing back then. Things have changed enormously. So every organization, every client that we work with at Eckerson Group is on a journey to modernize their data warehousing environment. And what we're seeing happening is not just data warehousing anymore. That was the only game in town. Now it really is just, as Eric was saying, one component in a larger ecosystem, which we call a modern analytics ecosystem, which truly, if designed properly, is a living, breathing organization that detects and responds to new events, new data, new requirements rapidly. It learns and adapts to the users using it, and it's highly tailored to every type of user and their requirements. So I've come up with here 10 characteristics of this modern analytics ecosystem, and I'll run through these. You obviously can read them here. Provide a little detail, and then I'd like to throw it out to our panel of Dave and Joy and Eric to see what they would add to this list, if anything, or how they would enrich things that I've mentioned here. So the first characteristic is that this is a customer-centric architecture. You know, traditionally we've built, I should say IT has built our data warehousing environments and our data architectures, and they tended as a result to flow from left to right, from source to target. But in today's world, with the new technology in this new modern analytics ecosystem, the flow in many respects goes right to left, from the end user to the data, backwards to the data. So that means we start not with a data model, but we start with who are the users and what do they need? What are their real requirements? And then we provide each type of user, whether it's a casual user, a power user, a data scientist, a discovery user, an application, or even an external customer or supplier. We give them all unique access points to this architecture. We give them access to points in the pipeline, essentially, where it makes most sense for them to come in and grab data. And sometimes it's grabbing actual data. It could be raw data. It could be summarized data, more for the power users. But for the casual users, perhaps it's more of a view of that information, or really it's just the application itself. It's the dashboard. It's the report. So designing those access points really, I think, is a key to the modern analytic ecosystem and designing it from right to left. The second characteristic is that this environment is adaptable, responds quickly to change. We can't afford data warehouses that take, months and potentially hundreds of thousands of dollars to add new columns, new fields, extend the schema. We still need those data warehousing environments as we've defined them in the past, but essentially we're backfilling them with other components of the architecture, like a staging area where we can dump all the raw data and persist it there and repurpose it as we need without having to gather it again. And we can ingest it both as snapshots as well as increments to give us flexibility in how that data is set up initially. From there, we can move that data into a hub by lightly integrating it by subject area and creating base tables that become an artifact for reuse, no matter what type of application requires it downstream. And then from that hub, we can create these bidirectional pipelines to support all these different types of use cases. One might be a data warehousing use case to support reports and dashboards. And when we build that data warehouse, we actually might take some of the artifacts inside of it, like dimensions, perhaps some data definitions, and move that back into the hub where it can be reused in other use cases. Discovery marts or data science workbenches might be other use cases that or use cases or pipelines in this environment. Number 3 is automated. These tend to be large environments, and the more we can automate them through rules and machine learning, the easier they are to manage, the more adaptable and resilient they can be. So we want to do things like when we ingest data, and today we're ingesting big data, large volumes at high velocity, let's inject them with metadata and then be able to, as soon as we acquire new data, be able to associate that with existing data sets, data elements already in the environment. Also, we could want to detect changes in the schema. So if something changes in a source system, it's automatically picked up at point of ingest, and the system can respond in a largely automated fashion. We can also do auto-profiling, auto-matching, and a number of other things to make this environment much more flexible, much more resilient, much more automated. Number 4 is elastic. Today's architecture allows us to separate storage and processing and scale each independently, and then only pay for what we use instead of paying for peak capacity. So this is a real breakthrough, especially in the cloud environment, either public or private cloud, that we can take advantage of in a data environment, especially one that has lots of volume and lots of workloads. Having this flexibility to scale up processing and storage as needed is a real breakthrough. Also, it allows us to deploy new types of applications, such as development environments, test environments, sandboxes, prototyping environments, spin them up, and then spin them down as we're finished with them. We've touched on flexibility already, the ability to support multiple types of users, casual, power, data scientists, but it also refers to flexible refresh rates, whether it's batch refreshes or mini batches or streaming. Also query operations, such as creating, reading, updating, deleting, data processing engines. So it used to be that everything had to be processed in a relational engine or an OLAP engine, but that's not true anymore. We have all kinds of engines from search to graphing to MapReduce and on that we can bring to bear on this data, whatever most appropriate. We've already talked about different types of pipelines, from data warehouses to data marts to discovery environments to data science sandboxes to real-time applications that require this data from the data warehousing environment. So in essence, this new environment, this modern data warehouse or analytics ecosystem, if you will, needs to be all things to all people and applications in an organization. Number 6 is collaborative, and that means, it used to be that IT did everything. They acquired the data, they modeled it, they delivered it, and they built the applications. Today, our environments are a collaborative effort between IT and the business. IT is doing things that don't require a lot of business knowledge. That's where they've really fell down in the past. So they'll take and ingest the data, they'll tag it, encrypt it, and create those base tables. And then the business will take over from there. They're hiring data engineers that can prepare this data using data prep tools and catalogs for purpose-built use cases. They're closer to the business, so they should be the ones who touch the data last before it's consumed by users. Number 7 is governed. As I mentioned earlier, we need to have governed access points. We don't want to give all users access to the raw data in this ecosystem, only those who are qualified and certified to do that. So we need a very stringent permissioning system, both to access data, to access pipelines, and access applications. We also need a strong data governance environment supporting this whole ecosystem, because without common data definitions, a common semantic layer, we just have a Tower of Babel and silos, just all running on the same platform. Ideally, this environment is simple, which is hard to do in a very complex world. But to be honest, for some companies, maybe their data warehouse is really just a BI tool with embedded data management environment and embedded database. We don't need to make things more complicated than they have to be. But truly today, a lot of large organizations are creating this ecosystem with a data lake, front-ending, a data warehouse, and other types of pipelines. Increasingly, we're seeing these environments go real-time, largely because the volume of data is so big that it's no longer possible to batch load the data. With the advent of IoT, Internet of Things, data volumes are increasing, and that data is coming in extremely fast. And our applications that use those are looking for anomalies, so those need to be real-time applications. As a consequence, we're seeing many, many more operational applications running off our data warehousing environment, and these need real-time data. Number 10, secure. This goes without saying. We need to have not only strong permissioning, but we need to have strong authentication. Data should be encrypted. And with the advent of GDPR and other privacy regulations, we need a way to identify personally identifiable information, mask that data, and track where it is in our environment using data catalogs, lineage, and other tracking tools. And then finally, for a bonus, if we truly are in a big environment, especially if it's in the cloud or in Hadoop, it needs to be resilient. In fact, Hadoop was designed to be resilient and assumes that servers are going to commit errors. So that environment is already built for resilience, built with backup and restore in mind. The cloud is also a way to gain some resilience because you essentially outsource the data infrastructure to a third party. Of course, a lot of these cloud platforms, especially the public ones, are a little bit immature, and they may go out on us without much warning, and we have to design our architectures accordingly. So these are 10+1 characteristics that I've seen a modern data warehousing environment needs to support, or what I'm calling a modern analytics ecosystem. So at this point, I'd like to throw this back to the panel here. And I think we've, it's at 4:20 now, so maybe a short discussion about anything you would add or delete from that list?
Well, we have one attendee asking a pretty interesting question. So would the self-service capability affect collaborative characteristics? Maybe I'll throw that over to Dave Wells. You know, self-service and collaboration kind of go hand in hand. What do you think about that?
Self-service and collaboration very much go hand in hand, and I actually was noting as Wayne was talking that in the self-service world, collaborative and governed sort of have to go together. So we can be collaborative in how we use data, how we do analytics, but we also need to be collaborative governance instead of the traditional hierarchical top-down governance. So, yeah, absolutely, collaborative is a key part of self-service, and architecture has to enable collaboration.
Yeah, that's a good segue to your section, in fact, but let me get some commentary from Joy King. You know, we are in a very much more multi-dimensional world these days. To Dave's point, it's not the up and down hierarchical world anymore, is it?
Well, you know, I think I like your 10+1, absolutely, and my own comment would be, I think by adaptable, I fully agree, but I'd like to go back to Eric's comment about Mike Stonebreaker. He is absolutely right. I always say one size doesn't fit all, and it never fits me. And so I would change adaptable to open, because open ecosystem is what customizes to a customer-centric. None of us, no technology in the industry, no combined integrated stack is going to be the answer. The answer has to be open, an open ecosystem. And then the other thing I'd say, and it speaks to the comment that you made, Dave, about machine learning, is that scale is what's missing. And here's why I'd say that. You think back just a short time ago to what we considered big, and it's considered small now. We have to plan for that, because change isn't going to slow down, and speed and volume isn't going to slow down. It's going to get faster. That's my feedback.
Yeah, that's actually an excellent point, and is another good segue into Dave's presentation here, because the proper architecture can handle scalability. With that, I'm going to hand the keys to Dave Wells. Take it away.
Okay, so the question we started with was, what is a modern data warehouse? And as I was putting my slides together for this, my conclusion was that the data warehouse isn't the problem. It's data architecture that's the problem. And if we solve the right problem, the data warehouse or data warehousing will find its place within a modern data architecture. So we need a modern data architecture that matches the realities of data management today. We're dealing with all kinds of things in data that we didn't deal with as recently as 5 years ago. Big data, unstructured data, data lakes, the questions of scale up versus scale out, Agile, and even moving from Agile to DevOps is becoming a big deal in data management. Self-service is important, as we discussed around collaboration. Advanced analytics, machine learning, AI are all driving this to different places. So we need an architecture that can adapt to all of those things. We need to apply architecture so that we build things that adhere to the goals of architecture, whether it's data architecture, systems architecture, building architecture, or bridge architecture. We build things based on architecture because architecture helps us to make sure that things satisfy their purpose, fit their environment, are compliant with codes and regulations, are resilient and sustainable through their lifespan, and are aesthetically pleasing. And I think aesthetically pleasing, when we talk about data architecture, connects back to one of Wayne's points, which was about simple. And simple in this complex data management world is difficult to achieve. So what I like to do in terms of aesthetically pleasing and simple is make a distinction between complex and complicated. We're working with a lot of complex data structures. We have to accept the complexity and architect to manage that complexity. Complicated is a different thing. Things are complicated because we took some action. Complicate is a verb. So as we think about modern data architecture, we have to understand and accept complexity and avoid complication. As we do this for modern data warehousing, we want to retain the benefits of data warehousing but not be constrained by them. So we want integrated data, we want subject-oriented data, we want non-volatile data, we need time-variant data for time series analysis and trending. Those 4 characteristics that Bill Inman itemized back in the early 90s for data warehousing, integrated, subject-oriented, non-volatile, time-variant, we need to retain all of those. So how do we get to the kind of architecture that's going to do this and do it for us well? Well, first we need to step back and ask, do we really need a data warehouse? We don't necessarily need a data warehouse. We need data warehousing. We need integrated, subject-oriented, non-volatile, time-variant data. But whether it's stored in a data warehouse, a data lake, or we call it something else, isn't really all that important. When we have data lakes and data warehousing, they must work together. They can't be competing sources of information. They have to be compatible. They have to work together. We should minimize the footprint of redundant data as much as is practical, but we need to organize data to serve everyone from data scientists who may want raw data from the data lake to the business manager who wants to continue to depend on data that is regularly published to him. Not everybody wants self-service. Not everybody wants the keys to the kitchen and to go cook their own meal. Sometimes they want it to be served. We also have to recognize the reality that legacy data warehouses exist, and we must accommodate them. People still use them. They're business critical. People depend on them. And in recent speaking engagements and classes that I've taught, I've run live polls asking how many data warehouses do you have. Very few companies today have one data warehouse. The bulk of people answer in the range of 2 to 5, and I occasionally encounter someone who has more than 10 data warehouses. So we need to architect around the realities of our legacy, and one of the important points, back to one-size-fits-all. The one-size-fits-all architecture doesn't exist any more than the one-size-fits-all DBMS exists. So we need to think about data warehousing in a different way as a component of modern data management architecture. There's been a lot of talk lately declaring the data warehouse dead. I'm going to say the data warehouse is not dead. It's alive, but it's not alive and well. And here are the reasons it's struggling today. It's struggling with growth in volumes of data, growth in numbers of users, growth in frequency of use, growth in variety of work cases, struggling with workload fluctuation. We run on-premises data warehouses where we have to be tooled up for peak workloads and have a lot of unused capacity when we're not at peak. It's challenging from a data center management point of view because it demands a lot. I can tell you that back when I was at the University of Washington and responsible for data warehousing, it didn't matter how carefully I estimated storage needs for an annual budget, I blew them out in less than 6 months. So managing data center from a storage perspective, from a processing capacity perspective, from an operations and cost perspective is challenging. We experience processing bottlenecks and delays. We have to wait for infrastructure anytime we want to add new increments to a data warehouse, new subject areas, new sources. We need more infrastructure, more storage, more capacity. That slows down our ability to be responsive. Data warehouses are now business critical, as I mentioned, but with them come risks, so we need to fully integrate data warehousing into our disaster recovery business resumption plans. They can be security and governance challenged, and we've already talked quite a lot around the complexities of database management, so we need to step up to these things in a different way. And one of the ways we can step up to these is data warehousing in the cloud. If I were to add to Wayne's list of 10+1, I would say that one of the criteria for modern data management architecture is cloud compatible at minimum and cloud native where practical. With the cloud, we become scalable and elastic. We get the benefits of that managed infrastructure so that we've eliminated or reduced data center overhead. We begin to save costs because we've cut the cost of hardware, staffing, power, cooling, floor space, etc. Through the parallelism in the cloud, we can increase processing speed and get performance gains there. With instant infrastructure in the cloud, we get rapid deployment. Disaster recovery becomes easier when we're running a virtual in the cloud data warehouse where we can save the state and physically save the whole thing as a file at any time. Security and governance we have to pay attention to. One of the common myths about cloud is that it's not secure. It can be tremendously secure with virtual private cloud with single tenant cloud. It can be tremendously secure. The thing we have to watch out if we're moving data to the cloud is that when we're moving that data back to our business applications, we're moving it across public internet. So it's not securing data at rest anymore that's the challenge, it's securing data in motion across a network. The cloud also, there are many, many, many options for relational database management systems in the cloud, so your existing schema and existing warehouse data are readily accepted. So when we think about modern data architecture, we should give a lot of thought to the benefits of cloud, and in particular cloud data warehousing. We also need to rethink how we talk about data. And I've started using this term data core because the term data hub tends to have a lot of different meanings to a lot of different people. In fact, Wayne and I use the term in different ways. But what we need to recognize is that we have a lot of different kinds of data out there: legacy data warehouses, operational data stores, old generation MDM, plus data lakes, some SQL, some NoSQL, analytic sandboxes where analysts can play. We need to think about this in a systematic way, and it doesn't necessarily mean this diagram. It means step back and think about what you call data stores, the purpose of each data store, how one data store relates to another, and use language that makes sense, and rethink architecture so that we stop gluing things onto an old architecture that's predicated on 1990s data warehousing, and start architecture again, greenfield from the ground up, redefine the architecture so all the parts fit together. We need to think about where the data warehouse lives in this architecture, if we're going to have a data warehouse, and I'll show just a couple of options here, but there are lots of possibilities. This option suggests that we can have the data warehouse outside the data lake, so data lake and data warehouse exist side by side. This diagram uses the data lake as a landing area for all incoming data. So I would no longer have a separate staging area for the data warehouse. The data lake would serve as staging for warehouse data. And then we can ETL or ELT from data lake to data warehouse. And they each have different purposes, as you see inside the box: landing area for incoming data, raw and refined data and sandboxes in the data lake. In the data warehouse, relational, subject-oriented, and historical, either Inman or Kimball architecture, spoke or bus, integrated, cleansed, aggregated. So this is one way that we might think about positioning data warehouse and data lake so they work together. Another way we might think about it is placing the data warehousing inside the data lake so that we have a data lake that encompasses all of the data that we're working with. It has a raw data zone, a refined data zone, so that we can work with all of this big data, unstructured data, and know which data is trusted and which data is curated and which data has simply been ingested and is there. And then we can begin to move data from raw data zone and refined data zone into the data warehouse. The data warehouse can be used as a source for populating analytic sandboxes. So another way of thinking about various uses for the data, various users of the data, and how to organize data to satisfy the needs of each of them, from data scientists who want raw data, big data, unstructured data, to business managers who want their published reports and published OLAP and dashboards and scorecards. What we have to do here is we have to build for the future. It is not a data warehouse problem. It's an architecture problem. We need to step back and rethink architecture. We don't necessarily need a data warehouse. It's okay to have a data warehouse, but we don't necessarily have to have a data store called a data warehouse. We do, however, need data warehousing. We need integrated, we need subject-oriented, we need time-variant, we need a way to retain the history that is lost from source systems, operational systems over time. Migrating to the cloud will help, but it's not the whole solution. Rethinking the topology for data lakes and data warehousing is the must-have. What I see in a lot of architectures these days is an old data warehouse architecture, a new data lake architecture, and some patch to make them communicate with one another that looks to me like a duct tape solution. So it's time for new architecture, and when we design this new architecture, it must be adaptable architecture. That, out of Wayne's points of characteristics for architecture, I'd say adaptable has to be way up there at the top of the list. And with that, I will pass it on to discussion, and I'd love to hear comments from the rest of the panel and from any attendees.
Sure, attendees, feel free to send your chat messages in or Q&A. I have to say, Dave, this concept of a modern data architecture is spot on. right? Because you're not talking about an object, you're not talking about one particular piece of technology, you're talking about a vision for how we, well, let's use the word, synthesize our information systems. I'll throw it over to Wayne for commentary too. What do you think, Wayne?
Yeah, the thing I see a lot of our clients struggling with is where to put the data warehouse, as Dave said, inside or outside the data lake. A lot of companies with dozens or hundreds of silos, data marts, data warehouses, are very tempted to just consolidate all of those things, lifting and shifting them into a data lake. Not necessarily re-architecting them, because that's a huge deal. Others are just content to outsource or offload the ETL or some of the detailed data from the data warehouse into the data lake. But this dividing line between the data lake and the data warehouse has been contested for quite a number of years now. And it's a moving target because the technologies underneath, relational and Hadoop traditionally, are evolving quite quickly to become more and more like each other, to be honest. But then we throw the cloud in, and that's changing the whole equation once again. With the cloud, we can really create a very modern architecture with processing and storage decoupled, with a built-in object store or staging area. And that's why a lot of companies are moving to cloud data warehousing environments or something larger than that, where warehousing is just one use case in a larger environment. So it's interesting times. This, Dave's definitely right about architecture first and warehousing and data lake second. So I definitely second that opinion.
Yeah, with the proper architecture, you can pivot quickly. I guess that's part of the point you're making, right, Dave? That with the right architecture, as business needs change, as market forces change, you can more easily pivot to address whatever dynamic is occurring, right?
You should be able to quickly respond to technology changes, business changes, requirements changes, data source changes. The reality is the pace of change is accelerating. It's not slowing down. If you look at what we've experienced in the past 3 or 4 years, that I think is tip of the iceberg.
Yep.
So we have to get in a position to quickly respond to any change that comes at us.
Yeah, that's a good point. And Joy King, do you want to respond while I hand the keys of the WebEx to you to do your presentation?
Yeah, I'd say I'd only make one change or one addition, Dave, to what you said, and I'm going to talk a little bit about it too. But when you talk about the future and the data warehouse and DBMS in the cloud, I'd suggest clouds, and I'll tell you why. So let's go to what I want to talk about. Now, I have to tell you all, I am a passionate history person. I love history. Now, I do read a lot of fictional history because that's the best way my brain can ingest it. There isn't a lot of fiction in the data warehouse IT space yet, so we'll see how that goes. But when I think about where we've come from, it often tells me where we're going to go. And if you think about the traditional data warehouse, it was built with, as Eric said in the beginning, with the infrastructure that we had. It was hardware and software put together. It was an appliance. It was built for on-premise because that's all it was. Storage and compute was coupled because that's how servers worked. All of those things were part of what was the traditional data warehouse. And part of it was the limitations or what the technology that we had at the time, and part of it was capitalism. Part of it was how to build a totally integrated solution that protects your business. And by your business, I mean from the vendor's point of view. But that isn't necessarily the best solution from the customer's point of view. So you guys had 10 plus 1, which was Wayne, and 5, I think, Dave, I counted on your summary slide. I'm down to 4. These are the 4 areas that I feel are critical in terms of thinking about the modern data warehouse. And whether it's a warehouse or a data lake, the modern analytics platform that as a company you need to rely on. And it's 4 categories. analyzing data in the right place, where it makes sense. It doesn't make sense to put all your data in the same place. It's not rational, it's not fiscally or economically reasonable, and it's not the right thing. But moving data just so you can analyze it also doesn't make sense. One of my biggest passions is freedom from underlying infrastructure. The greatest advantage that we have today is that there is choice. We have clouds, not just a cloud. We have on-premise. We have flexibility to ensure hybrid deployments. Because if you really look at this as a software-only story, then you do have freedom. But, as I said, capitalism does drive industries to build much more tightly controlled solutions or packages. And unfortunately, that can prevent that adaptability that everybody is mentioning and that I'm calling, open. And then separation of compute and storage, that is a great thing to take advantage of with today's technologies. And I will give the cloud providers credit for deploying this in a way that makes it real to all of us. Using compute when you need compute, using storage when you need storage, and where you need it. That absolutely makes sense, so why wouldn't we take advantage of the separation of compute and storage? But let's be clear, S3 equivalents and all sorts of other options on-premise are also allowing very modern on-premise data centers to move toward the separation of compute and storage. And finally, and maybe one of the most exciting aspects of the modern data warehouse is the opportunity to apply advanced analytics and machine learning to all of the data. If we think about what's really changed, data volumes are huge. And let's be clear, machine learning, AI, whatever we want to call it, isn't going to give us the kind of predictive accuracy that we need if it doesn't have access to the broadest amount of knowledge of data. Downsampling, using sets of data, is moving data and moving down samples because it takes too long to move data. That is all a direct compromise. So for me, these are the four categories. And if you look at this, let's think about analyzed data in the right place. It makes sense to store certain data in open source formats like Orkin Parquet, store it on Hadoop, store it in Amazon S3. But you also want the ability, as Dave, you mentioned in your architecture, to be able to connect, to join that data lake data with much more hot or valuable or whatever you want to call it data in your centralized analytics platform or data warehouse. You want to be able to create joins. You want to be able to explore all of your data, wherever it is, on any underlying infrastructure with the same SQL capabilities, with the same time series, geospatial, advanced pattern matching, all of that. It doesn't matter where it is, it matters that you can keep it where it makes sense. And then, as I mentioned, freedom from underlying infrastructure, I can't stress enough how critical this is. I've been in this industry for a long time, but it was only in the last few years that I learned about a term that I'd never heard of before. I'll be honest, I'd never heard data egress. I didn't know that there was such a phrase that getting data in to a particular cloud platform was seamless, easy, inexpensive. But let's talk about getting data out. Let's talk about deciding that you want to move from one public cloud to another. How easy is that? It's not easy if you are tightly integrated into a single provider's cloud stack. And frankly, there's a lot of vendors in the market that do the same, that offer a solution on-premise and the same branded solution on clouds, but the product itself, the software itself, is not the same, meaning the ability to seamlessly move between infrastructures that makes sense when it makes sense is a lot harder than it looks. And that freedom, that software-only, seamless, unified engine is critical. And it's something that I feel a lot of passion about. And then, as I mentioned, separation of compute and storage. It doesn't make sense to not take advantage of advances in technology that lower your infrastructure bills. Let's be clear. That's what we're talking about here. Separating compute and storage means using lower cost storage for all the data, not having to say, well, which data do I keep? Which data should I throw away because it's too expensive to keep it? No. All your data, use the compute resources that you need on the data where you need it, and take advantage of the separation of compute and storage, which is a new technology capability that we all should be enjoying, which wasn't available to us when Dr. Stonebreaker began the journey with Vertica. And that brings me to the last point. And the advanced analytics and machine learning functions are critical. Now, in machine learning, one thing that frustrates me, just like I mentioned with data egress on infrastructure, is how algorithms have become the shiny new object. It's interesting to me that Kleenex means tissue. Well, algorithm means machine learning, but it's not. Machine learning is an end-to-end workflow. Everything, as we know, from data preparation to modeling to evaluating the models to see which one is the most accurate to deploying those models into production applications or production analytics. And the algorithms are not the end-all be-all of machine learning. So how do you do all of that in a common unified analytics platform without having to move the data in, out, back, forth, downsample? All of that is one of the key aspects of a true modern data warehouse. And that brings me to the first slide that shows the logo that I'm most proud of. Dr. Stonebreaker is, as Eric, you know, and Dave and Wayne knows, and probably everyone else on this webinar knows, is not only the founder of Vertica in 2005, but the architect behind both Ingress and Postgres. Who else better to know what the next generation of analytics needed than the guy who designed the whole industry? And Vertica is today the industry's only infrastructure agnostic, unified analytics platform. You can analyze your data where it makes sense using the full suite of advanced analytics and in-database machine learning without moving your data. Protect you from the challenges of a tightly integrated stack that means the door is locked, and all at reliable performance at enormous scale. And let's be clear, we get pushed pretty darn hard. I have to tell you, our R&D teams, our engineering teams in Vertica, they take a lot of pressure from the largest companies in the world, the companies that many of you know, like Uber or Twitter or other companies that have enormous reliance on volumes of data. And that's why they rely on Vertica. So for me, these four categories are key to the future and the now of the modern data warehouse. And Eric, I think now I get to turn it back over to you.
All right, maybe first some commentary. I guess I'll throw it over to Dave Wells to start here. I really think you've hit the nail on the head with focusing on architecture, because the right architecture, it has to be understood. Obviously, it has to be documented. It has to be functional. But in that case, if all those three things are true, then the team can look at any given situation and figure out a fairly rapid path toward resolution, right?
Yeah, I think that's true. What I found interesting in Joy's talk was she really nailed two things that architecture must address if it's going to work well and if it's going to be adaptable. And that is, we do too much of unnecessary moving of data. To the extent that we can minimize data movement, we're doing the right things, and that's a good thing. And the other one is when we have too many technologies in play, too many platforms from too many different vendors, we're breaking that seamless user experience for the data analyst in moving from data to analysis to insight. That should be as seamless as is possible. And we can address both of those things in architecture. If we minimize data movements, we gain performance, we gain efficiency, but we also gain security, because moving data across a network, in particular cloud where we're moving data on public network, creates a security risk. And the more copies of data that we have, security sensitive data, the greater the exposure of that data, the bigger the perimeter we have to protect to secure that data. So those were the two big powerful things I heard that every architect needs to adapt, is minimize the movement of data and minimize the copies of data. And at the same time, back to Wayne's first point about customer-centric architecture, one of the first things in customer-centric is that seamless user experience.
And you know, I think, Dave, the other thing to think about is with all of that data, having access to all of that data, it's not just more secure without having to move it. Absolutely, I couldn't agree more. But also, you truly advance the accuracy of predictive analytics, right? We're pivoting from what happened, what's happening, to what's going to happen. We know that. We're all talking about that.
Yes.
But in order to do that, you have to have all of the data, not parts of the data, not samples of the data. So I think everything you said, plus the improvement in predictive opportunity, is really powerful.
Right. Downsampling takes away accuracy.
Yes.
So
yeah,
Joy,
but Wayne, I'll bring you in. Go ahead.
Joy, this is clearly not your father's Vertica here, because I think what you're insinuating is that with Vertica, you are not attached to a storage platform anymore. And that wasn't always true. I remember one of your flagship customers, Zynga, they had the largest Vertica implementation, 120 nodes or something like that. Half of those nodes were for one instance of a data warehouse, and the other half were for a replica for exploration. So it sounds like you decoupled storage from your processing, and now you can run Vertica engine against anything, including, say, S3. So I assume that's true?
It is absolutely true. So let's sort of break apart what you said a little bit. First, it's been a while that Vertica has been able to analyze data in S3 and on Hadoop without moving the data. That isn't new. That actually is a function that we have using external tables and allows, but what's special about it is if you think about that read-write capability in external tables, it also allows you to perform joins on the data between the data in HDFS or S3 with the data in Vertica. So that's step one. Now we are currently finishing up a very popular public beta and will very soon, you know, I can't say when, but very soon, be announcing Vertica in Eon mode, which is already out there in public beta on Amazon Web Services, that does exactly what you're saying, which is separation of compute and storage, so that what you are doing is actually deploying Vertica in Eon mode. And in this architecture, you're able to put all of your data in your dedicated S3 bucket in ROS format, deploy the number of nodes that you need for any particular workload, spin them up, turn them down, hibernate the database overall, and still access from that same Eon mode deployment data in data lakes of S3 and on Hadoop. So yes, this is a new step for Vertica. The S3 and HDFS is not new. We've had that for a while. Eon mode is definitely going to be very exciting as it goes to general availability shortly. And the company that you mentioned is very, very excited about that next step. I can tell you that as well. Very excited, because it gives a tremendous opportunity to save a lot of money on infrastructure, Amazon Web Services infrastructure, but also dramatically simplifying the administration of the databases with variable workloads.
Yeah, that's
good to hear. I mean, you're certainly modernizing your own database architecture to stay abreast of what's going on in the industry. So that's
well, and
marvelous.
you know what else is cool? I got to tell you guys, it would have been a very interesting strategy for us to create this new Vertica in Eon mode, and you choose which one you buy. Except we didn't want to do that. We still believe in a single unified engine that can be deployed across multiple clouds, on-premise, natively on Hadoop nodes. So we took a very significant set of engineering resources, and we chose to make Vertica deployable in enterprise mode, which is what tightly coupled storage like we have today, and Eon mode. So you're still talking about one RPM, one unified analytics engine that you choose how you deploy that database for that use case, and that gives you that single unified engine freedom from having to have different databases with the same logo in different deployments, one Vertica, but taking advantage of separation of compute and storage in the Amazon Web Services environment and more clouds and on-premise to come. So it's pretty powerful.
So I know this is a huge issue for large organizations that are moving most of their data processing resources to the cloud, but are still in a hybrid mode and will be so for a long time.
Yep.
And they are very cautious about getting locked into one cloud platform.
Yeah.
So to have an environment that gives them the ability, I assume that you can, with this Eon mode, maybe also do hybrid deployments, so you can have a little bit on-premise and in the cloud, and maybe across public clouds. That would be ideal if you can do that.
That is absolutely our roadmap. The first deployment of Eon is on Amazon Web Services, but we are very true to our mission, and we have some of our founders that keep a close eye on that mission. And so we have a roadmap that does exactly what you're saying. But again, even today, if you are deploying, putting S3 as your backup, or you have a large Hadoop data lake and you're deploying Vertica, you have the ability to analyze that data in the right place. And Eon mode is not the only way to do that. But Eon mode, when it becomes generally available, will be Amazon Web Services in the short term, followed by other major cloud and on-premise deployments on our roadmap, and we're very committed to that.
Yeah, that's great stuff. And, you know, I'm thinking about an article I read a few weeks ago by a good friend of ours in the business, Tony Baer of Ovum, and I'll throw this over to you, Dave, and then maybe some comments from Wayne and Joy to close us out. He had an article where he said, is cloud now the de facto data lake? And his point was that hybrid cloud is here to stay. Multi-cloud environments are never going to go away, it seems to me. And to Joy's point, why not have a solution, and to Dave's point, an architecture that allows organizations to access data from these different environments as and when needed, as opposed to the old way of pulling all this data and forklifting it into a giant single warehouse to do your analysis. So, Dave, first over to you. I think he hit the nail on the head. I think that cloud is the de facto data lake these days, and that modern data warehouses need to be able to leverage traditional on-premise data, but also pull data from various cloud environments as and when needed. What do you think?
I think he's absolutely right on the money. The reality is most companies today are living in a world of on-premises plus multiple cloud platforms, and you have data everywhere. You have data in software as a service applications, maybe Salesforce, maybe Workday, maybe many other things, and they exist in different cloud environments. You may be running Hadoop with cloud instance and doing your data warehousing there. So being able to cross all of these boundaries of where data is stored and do it as if there are no data borders, I think is the real challenge.
Yep.
And the thing that it looks like Vertica steps up to.
Yep. Wayne, what do you think?
Well, you know, my friend James Serra said, do you want to be in the air conditioning business? So a lot of companies have realized, no, they don't, and they're moving, finally, it's taken 10 years, but they're moving headlong into the cloud. But for big companies, that's taken a while, but it's surprising how many are just doing a real hard break and moving everything up there. And certainly the cloud makes it much more, once you outsource your data infrastructure, you're saving a ton of money. And even if there are additional costs in the cloud, no one's saying it's inexpensive. There's ways to manage it so that it's not overly expensive. But the net, if you take the total cost of ownership, moving all your data into the cloud is going to be a huge gain for companies.
Enjoy some closing remarks from you. I think that the headwinds are there for traditional data centers. What was the joke I heard someone say? Friends don't let friends build data centers anymore. The key is the cloud is going to be the prevailing source for data going forward. But on-prem is going to have a tremendously long tail. What do you think?
I completely agree, and I am not a big believer that any of us can predict the future. I think what we have to do is be prepared for that adaptability, that change, and not allow ourselves to be locked in again and again. Because the industry, the world we live in, is designed to move us into a place where sticky solutions make it harder. So it's really important for everyone, wherever they believe the industry is going, to not put all their money in one place, because that's the kind of bet that can often have you go home empty-handed.
Right, and I'll let you answer one more question from an attendee. Joy, we had a very specific question come in of why would someone use Vertica over, let's say, Redshift on S3?
So I think that that's a really good question. One thing would be that, as I mentioned, that if you don't want to find yourself with a single underlying infrastructure option, then Redshift is available on Amazon, but it doesn't go anywhere else. And that's a challenge because, things change. The other thing that's important is the separation of compute and storage, the ability to analyze data in not just S3 as a data lake, but only have your compute nodes call on the S3 bucket for your database when they're needed, to turn them off, to turn them on, and hibernate. That's a very unique capability for Vertica. The other thing that I'd say is Vertica is designed for efficiency. With Eon mode, being able to turn on and off your compute nodes is very important to us. We don't make any money from underlying infrastructure. How much infrastructure you use doesn't benefit us. What benefits us is optimizing the software for performance and cost efficiency. And I would say that cloud providers with solutions don't necessarily have the same motivation.
Yeah, good point. And one last question for you, Joy, just because it came in here at the last second. What about a comparison to Snowflake, which, let's face it, is a very, very interesting cloud-first, dynamic, elastic sort of model for data warehousing?
I completely agree. And I think that Snowflake has a lot of things that I've talked about. What it doesn't have, first, is the maturity of a Vertica that was founded by somebody as well-respected in the industry as Michael Stonebreaker. But you heard me talk about external tables, the ability to analyze data external to the database in Hadoop in S3. Snowflake doesn't do that. We talked about the importance of advanced analytical functions like time series, geospatial, pattern matching, in-database machine learning. Snowflake doesn't have any of that. And let's be clear, I wouldn't expect such a young company to have this kind of advanced analytics in database machine learning and the ability to analyze through external tables and joins. All of that is the benefit of having the experience that Vertica has. I could go on a few other things, but I think those are the things that really set us apart. And while I respect the smaller use cases that could be useful for companies who want to try Snowflake, I'd be careful not to go too far too fast.
Good point, folks. Well, we burned through over an hour here, an hour and 5 minutes. Big thanks to all of you out there for such excellent questions. These are very dynamic times, but I think our attendees recognize that our panelists today made some really, really good points, and I have to say that the key is architecture. It really always has been the key. It's just more important now because of just how much data is out there, how disparate these data systems are, and how much pressure the volume and the unwieldy nature of all this data provides on traditional architectures. So think about it, think long and hard about it. Feel free to hop online to Eckerson.com or, of course, Vertica.com/try to try out Vertica, or InsideAnalysis.com. With that, we're going to bid you farewell, folks. Thanks again for your time and attention. This is part 2 of the Synthesis Webcast series in the Modern Data Warehouse. Catch us next month as we do part 3. With that, we're going to bid you farewell, folks. Take care. Bye-bye.